Hi, I'm Sara Romiti, and today I will be presenting our paper called RealPatch, a statistical matching framework for model patching with real samples. In our work, we deal with the problem that models can take advantage of spurious correlations caused by subgroup imbalance within the training data that might not always hold up. Therefore, we will have models that perform well on average but poorly in the worst-case subgroup. In the case of the Celebrate dataset, for example, there is a spurious correlation between the binarized gender and the blonde-not blonde hair color. It will lead the model to have a high average accuracy, but also a high error for the two subgroups not blonde female and blonde male. Something similar happens in the case of the waterbirds dataset, where the bird type waterbird landbird is spuriously correlated with the background water land. For this reason, the goal is to learn models that improve subgroup performances without seriously damaging the average accuracy. We here propose our RealPatch framework, which consists of two stages. The first stage is statistical matching, which takes in input the dataset and the binary attribute Z. Z defines two groups and is spuriously correlated with the target label Y. In the Celebrate example, Z is the gender that defines the two groups male and female and is spuriously correlated with the hair color. The output of stage 1 is the matched dataset that is obtained by first estimating the propensity score and adjusting it with temperature scaling, where the propensity score is the probability of being in one of the two groups. So here is the probability of being female. Then we use the propensity score and the fixed caliper to restrict the dataset by filtering out extreme samples. After that, we compute the pairwise distance for each sample and use the standard deviation-based caliper to filter the possible pairs according to a maximum propensity score distance. Finally, for each sample, we select the closest sample in the opposite group. Here, we can see a few examples of retrieved match pairs for the four datasets we considered. Again, for Celebrate, we want to predict the blonde-not blonde hair color, which is spuriously correlated with gender. So in stage 1, we will match male to female and female to male. As we can see, matching is able to preserve attributes such as hair color and its shape, pose, and sunglasses. The second stage is concerned with the prediction of the target label Y. It is obtained by minimizing a loss that combines an SGDO objective function computed on the entire dataset and the self-consistency regression term applied to the matched pairs found in the previous stage 1. While the SGDO objective accounts for the worst-case subgroup performance, the form of the regression term induces the model prediction to be subgroup invariant by enforcing the predictions of the two elements of each matched pair to be consistent with each other. In the results here, we compare our RealPatch method against different baselines and show that it can improve the worst-case performances. Note that the Camel baseline is a model patching approach that uses generative adversarial network to perform intra-class inter-subgroup data augmentation. As such, it is not applicable to small training data such as iWelcomeSmall, which has around 2,000 images. Here, we evaluate the aggregate accuracy, the robust accuracy, which is the lowest one across the four subgroups, and the robust gap, that is the maximum accuracy distance between the four subgroups. We show the capability of our framework on three different datasets: Celebrate, Waterbirds, and iWelcomeSmall. iWelcomeSmall is a subset of the iWelcome dataset, whose task is to distinguish between two animal species spuriously correlated with two camera trap locations. The results are the average performances over 3 runs, and in bracket we report the standard deviation over the 3 runs. As we can see, RealPatch is able to construct a model that is robust across subgroups with high robust accuracy and a small robust gap. In all methods, we observe that degradation of the aggregate accuracy is necessary to improve the worst-case subgroup performances. However, RealPatch creates the best trade-off between the aggregate and robust accuracy than all the other baselines. In our paper, we also show how our framework can be used to reduce dataset and model leakage in a 211 class classification setting. For additional details and results, please go check it out. Thank you.